Good morning today. I'm your chemistry teacher. I'm Ranu Ramanayaka, a chemical engineer. I'm the teacher who conducted your online class. Here onwards, you can join our online class to study chemistry. I will supply all the needed material to your house. We have planned to supply all the needed printed materials to your house next month onwards. For these 2 weeks, it's better if you write a note with my guidelines. Please keep a paper and a blue pen and a black pen like those needy materials for your work. Let's start our lesson. We are going to study about chemistry. Therefore, we need to have an idea about chemistry. First today, what do you think about chemistry? What may be the definition of chemistry? So we can write that chemistry is the study of behavior and properties of matter. Chemistry is the study of properties and behavior of matter. What is chemistry today? Chemistry is the study of properties and behavior of matter. Chemistry is the study of properties and behavior of matter. Then today there is a new word, matter. It's not new for you really. Then what do you think about matter? What is matter? We define matter as anything which occupies a volume in the universe and has a mass. Anything with a mass and a volume can be defined as a matter. What is matter today? A matter is anything which has a mass, and which has a volume. Matter can be defined as anything which occupies volume from the universe and which has a mass. So now we know what is chemistry. Chemistry is the study of properties of behavior of matter. Properties of behavior of matter. Then matter is anything which occupies a volume from the universe and has a mass. We can define anything which has a mass and a volume as matter. Now we are going to talk about matter. So we can divide matter into 3 groups, or we can divide matter into 3 subtopics. We can divide matter as, there are 3 states of matter. So we can divide matter as solid state, liquid state, and gaseous state. So we can divide matter as solid state, liquid state, and gaseous state. So we should remember some properties of matter. I will explain these properties with the help of a tube on the computer. First we have to write these definitions. So please take a paper and write the definition of chemistry. Put a topic. The main topic is chemistry. Right below there, chemistry is the study of properties or the behavior of matter. Chemistry is the study of the properties or the behavior of matter. Write the definition quickly today. You should be able to write notes quickly, then you can write the chemistry paper in the allocated period. Otherwise, the time allocated will not be enough for you to complete the chemistry paper. So, write quickly. Chemistry is the study of properties and the behavior of matter. Then today, write the definition for matter. Put a subtopic matter. What is matter today? Matter is anything which occupies a volume and has a mass. Matter is anything which occupies a volume and has a mass. Write quickly. Matter is anything which occupies a volume and has a mass. Then today we can divide matter into 3 states. Write it. Matter can be divided into 3 states. 3 states. First one solid state. Second one liquid state. Third one gaseous state. Solid state, liquid state, and gaseous state. Write quickly. So today, now we know the definition of chemistry and we know the definition of matter. So then we have to study the properties of these states of matter. What are the properties of solid, liquid, and gas? Now let's consider the properties of this matter using the animation in the computer.
Okay, these are the properties of the 3 states of matter. If you first consider the solid state, we know that every solid has a fixed shape. Since the atomic arrangement of a solid is they have a high dense, and the atomic arrangement of solids are very tightly packed. They have a fixed shape. Since of the fixed shape, every solid has a fixed volume also. Then we know that since the atoms are tightly packed, we cannot compress them. The empty spaces between atoms are very low, so we cannot compress them. Therefore, we can define the compressibility of solids are very low. After that, Pute, rate of diffusion is very low. What do you think about the rate of diffusion? What's the meaning of rate of diffusion? Rate of diffusion means the movement of atoms from one place to another place. We know that the movement of atoms of a solid will not occur since the atoms are tightly packed. So the rate of diffusion is very low. Then Pute, we know that expansion of volume, if we supply heat energy, the volume expansion will be occurred since of the thermal energy. So if we supply thermal energy, we know that the volume of atoms will be increased. So then if we consider the density of atoms, the density of solids, since atoms are tightly packed, we know that density is equal to mass over volume. So density also will be very high since the tight atomic arrangement. Then Pute, likewise, if we consider the properties of liquids, we know that liquids don't have a fixed shape, but they have a fixed volume. Every liquid has a fixed volume. If you consider the shape of a liquid, every liquid takes the shape of the shape of the container. Every liquid can take the shape of the container. So then if we consider the compressibility of a liquid, we know that liquids also cannot be compressed. Since if we try to compress a liquid, as an example, in a syringe or an engine, we know that if we try to compress a liquid, the syringe or the cylinders of an engine will be damaged. I'll show you those things at our physical class. It's really hard to show those things or explain those things using this virtual classroom. So we know that the compressibility of a liquid is very low. With the help of hydraulic jack, we can explain that. We know that if we use a hydraulic jack, it will not be compressed after lifting the jack. So the compressibility of a liquid is very low. Then if we consider the rate of diffusion, we know that the rate of diffusion of a liquid is higher than a solid but less than a gas. We know that the particles of a liquid can move from one place to another place, so the rate of diffusion is higher than a solid. Then if we consider the volume expansion using thermal energy, if we boil water, we know that the volume of the water will be increased, so the volume expansion is slightly greater than the expansion of solid, but it is lesser than the expansion of gas. So again, if we consider the density, we know that the particles of a liquid are not densely packed as much as solid. So if we consider the arrangement of particles of a liquid, since the loose arrangement, liquid particles or a liquid has a low density or less density than a solid, but it has a high density than a gas. Then if we consider the properties of a gas, we know that gas does not has a fixed shape. It takes the shape of the container. If we put a rectangle or a cubic container, the shape of the container is cubic. If we use a spherical container, the shape of the container is spherical. So gas has any gas does not has a fixed shape, and they do not have a fixed volume also. Any gas can take the volume of the container. So if we insert a gas to a 5 cubic meter tank, the volume of the gas is 5 cubic meter. Then if we insert gas to a 5 liter tank, the volume of the tank gas will be 5 liter. So then if we consider rate of diffusion, the rate of diffusion is very high comparing with solids and liquids, since the atomic arrangement of a gas are very loose. They have a very loose arrangement, so the rate of diffusion is very high comparing with solids and liquids. Again, the volume expansion is very high since the loose atomic arrangement, and the density is very low. So these are normal properties. I think you had studied this from your O levels. So please remember these things since there are some past paper questions from this part. So it's better if you remember all these properties.
Okay, Pute, we have discussed the three states of matter. What are the states of matter? We know that solid state, liquid state, and gaseous state. So, Pute, if we consider the formation unit or the atoms in our world or the elements, we have 118 elements in our periodic table. We have printed the periodic table also there. We will deliver it to you as soon as possible. So we have 118 elements in our periodic table. You know, the rows of periodic table are called as periods. These are periods. And the vertical columns of periodic tables are called as groups. So today, if we consider our new periodic table for advanced level, there are 18 groups in our periodic table. There are 18 groups in our periodic table, and out of 118 elements, only 100 elements are clearly identified, are being identified for their properties, and 18 elements have been studied by scientists for the exploration of new properties. So now we use only 100 elements in our periodic table, but there are 118 elements today. So out of these 100 elements, you should remember the first 56 elements today. You should be able to remember the first 56 elements in the periodic table. So don't worry today. We'll give you some short note or short methods to memorize those things. I'll teach you some methods to remember the group elements in group wise. So here today, we should be able to remember these things. There are 118 elements. Out of 118, we use 100 elements. We have to study about 100 elements. Out of those 100, for advanced level, we need only first 56 elements. So if we consider these 56 elements or these 118 elements, we should be able to divide these elements into those three categories which were discussed at the last part, state of matter. So we should be able to divide these elements to solid state, liquid state, and gaseous state. So first of all, if we consider the liquid elements in our syllabus or in our periodic table, in the world there are only 2 liquid elements today. What are those? Can you remember the liquid elements in our periodic table? So if we consider the liquid elements, those are mercury. I think you have seen mercury in the laboratory. Mercury are used in thermometers. Then the next one, what is the next element? In liquid state, there are only 2 elements. First one is mercury. I think most of you have seen that. And the second one is bromine. Bromine. You should remember the color of bromine today. We don't need the color for this first lesson, but you will surely, you will most probably need those colors in inorganic lessons or in the 6th lesson. So it's better to remember these colors from the first lesson. Then it will be easy for us to learn those colors. So if we consider bromine, it's reddish brown gas. You should remember the color today. Reddish brown gas. Bromine is a reddish brown gas. So now you know that there are only 2 elements in the periodic table. There are only 2 elements in the periodic table in liquid state. So first one is mercury, a metal, bromine, a non-metal. And you should remember the color of bromine. it's a reddish brown gas. Bromine is a reddish brown gas. So okay, here's a small video clip for the identification of mercury and bromine. Okay, Uday. So you have seen what's the nature of mercury and bromine, and Uday, you have seen there is a metal called gallium in that video. That's a special metal. You will have that metal in your school laboratories. You can see that metal in your school laboratories. Gallium is a special metal. Although gallium is in solid state, it will be converted to liquid state. If you get into your hand, it will absorb the heat or the thermal energy from your body, and the liquid solid state will be converted to liquid state as soon as when you get a small gallium bar into your hand today. So gallium is a special element. The nature of gallium is mostly like mercury. So you have seen that in that video which we played a little bit ago. So when you return to school again, you can see gallium at your school laboratories. Then today, now we know that there are two liquids in our periodic table, mercury and bromine. Then there are 11 gases in our periodic table. You should remember these things, since we have got some questions, nearly like 8 or 9 questions from these parts in our past papers, in our near past papers. So you should be able to remember these things. There are two liquids, mercury and bromine. Bromine is a reddish brown gas. You should remember the color as reddish brown gas. Then there are 11 gases. For gases or gaseous state, there are 11 gases. We should remember all these 11 gases. So first of all, studying these 11 gases, we should be able to remember the 18th group of the periodic table. If we consider the 18th group of periodic table, we can see that there are 6 elements in the 18th group. They are helium, neon, argon, krypton, xenon and radon. What are these today? First one is helium. You have already known this one. Helium, neon, argon, krypton, xenon, radon. If you don't know these names, please write those things. Helium, neon, argon, krypton, xenon and radon. So we can easily remember these things using a short method. Heneaxer. If you remember Heneaxer, he, ne, a, ser, Heneaxer. So using this phrase, we can easily remember these things: helium, neon, argon, krypton, xenon and radon. So out of these 11 gases, there are 6 gases here. Out of these 11 gases, there are 6 gases here. So there are only 5 gases left. What are those gases today? You have already known that gases: hydrogen, nitrogen, oxygen, fluorine and chlorine. These are diatomic gases. Hydrogen, diatomic means there are 2 atoms combining these gases. Hydrogen, nitrogen, oxygen, fluorine and chlorine. Okay, there are 5 gases, and here in the 18th group there are 6 gases named as noble gases. We call these as noble gases. Noble gases. So the addition of these 2 is 11. So there are 11 gases in the periodic table. You should be able to remember these things. How can we remember the 18th group? Heneaxer, helium, neon, argon, krypton, xenon, radon. And there are hydrogen, nitrogen, oxygen, fluorine and chlorine. So there are 2 liquids, mercury and bromine, and there are 11 gases: helium, neon, argon, krypton, xenon, radon, hydrogen, nitrogen, oxygen, fluorine, chlorine. And out of these 13 elements, all other elements are solids. So if we consider solids, out of these 11 gases and 2 liquids, all other elements are in solid state. So most of the elements in the periodic table are in solid state today. So you should remember these states. Today, let's take a small note from this part. Please put a topic: periodic table. Periodic table. Put a topic today: periodic table. Today we have to discuss about periodic table at the end of this first lesson, but here we will take a small idea from the states of matter. Periodic table and the relation between periodic table and the states of matter. Write down today: although there are 118 elements in the periodic table, although there are 118 elements in the periodic table, although there are 118 elements in the periodic table, only 100 elements only 100 elements have been discovered with all the properties. Discovered with all the properties. When we consider the states of these elements, there are a lot of elements in the solid state. So we write a small subtopic after the sentence. Elements in liquid state. Write a small subtopic. Elements in liquid state. And write these two elements, mercury and bromine. We know that there are two elements only in liquid state, mercury and bromine. Write the color of bromine within brackets as reddish brown. The two elements of liquid state are mercury and bromine. Bromine is a reddish brown liquid. Or we can see the color as orange color, reddish brown or orange color. You can use orange color also, orange color or reddish brown color. Okay, there are two elements in liquid state and there are 11 gases or 11 elements in gaseous state. So put the next subtopic as elements in gaseous state. Put the next subtopic as elements in gaseous state. Right, today there are 11 gases in the periodic table. Write quickly. There are 11 gases in the periodic table. And first write these 18 group elements. Write these 18 group elements. What are the 18 group elements? Helium, neon, argon, krypton, xenon and radon. These are noble gases. Helium, neon, argon, krypton, xenon, radon. These are noble gases. And there are 6 gases in 18 group. How can we remember these today? Write the short method if you need. Helium, neon, argon, krypton, xenon, radon. Helium, neon, argon, krypton, xenon, radon. Okay, I have written these things. There are 6 gases in the 18th group and there are 5 other gases. What are those? Hydrogen, nitrogen, oxygen, fluorine, chlorine. Hydrogen, nitrogen, oxygen, fluorine, chlorine. There are 5 gases here and 6 noble gases here in the 18th group. So today you should remember the 18th group elements. Likewise, we can remember first group, second group and all the 18th group in our further lessons. So there are 11 gases, hydrogen, nitrogen, oxygen, fluorine, chlorine, remember all those 5, and there are 6 noble gases in 18th group. Okay, so out of all these 13, all other elements are solid. You should remember all these things today.
This is your new periodic table for advanced level containing 18 groups. I think that you have already seen this. So this is the 18th group which I told you which is named as the noble gases. So there are 7 elements in this new periodic table, but we don't consider the last one since the chemical properties of that one has not been revealed yet. So we consider noble gases as the first 6 elements: helium, neon, argon, krypton, xenon, radon. Then so here is 6 noble gases. Then there are another 5 gases: hydrogen, nitrogen, oxygen, fluorine and chlorine. So there are 11 gases and there are 2 liquids, here bromine and here mercury. So there are 2 liquids and all other elements are solids. I think you have seen the nature of gallium. Gallium is here. So you can consider the properties, or you can examine the properties of gallium at your school laboratories.
At the same moment. So if we talk about chemistry, it's the real subject that makes your Z score. I think you know about the Z score. Z score is the pass mark or cut-off mark to the university. So the Z score is mostly based on chemistry subject. So if you get a higher rank to chemistry, then you will be able to get a higher results for the Z score with the help of the results of the chemistry. So therefore we should know the marking scheme of chemistry paper. So if we consider the marking scheme of chemistry paper, we generally divide chemistry into 4 parts. Everywhere in the world, chemistry is divided into 4 parts. The first part is general chemistry. We have 14 lessons for 14 units for the complete chemistry subject for advanced level. So, general chemistry, we will get 9 marks out of 100 marks. The total mark for the paper is 100. The real mark is 1000. We will get the total marks from 1000, but it will be further reduced to 100 marks. So for general chemistry, we have 3 lessons: first lesson, second lesson, and third lesson. We will get 9 out of 100. Then the second part is organic chemistry. Organic chemistry, we will get 22 marks out of 100. Then third part is inorganic chemistry. Inorganic chemistry, we will get 23 marks out of 100. Then last part is physical chemistry. Physical chemistry, we will get 46 marks out of 100. So these are the parts of our syllabus. So for organic chemistry, we have 7th lesson, 8th one, 9th one and 10th one. Inorganic, we have 6th lesson. Physical chemistry, we have 4th lesson, 5th lesson, then 11th, 12th and 13th lessons. So this is the normal structure of our syllabus or the structure of our marking scheme. So you will get some MCQs from this first lesson. You can surely get nearly 3 or 4 marks out of 100 from this first lesson. So I will state those things when I teach. I will state all the important points. So you have to state or you have to write all the important points with a colorful pen. So you should keep some color pens with you. Okay, now you have a general idea about the structure of our marking scheme. So now we know what is chemistry, then what is matter, then what are the states of matter, and what are the physical properties for the properties of matter. So you should remember those things. Most probably we will get an MCQ from these parts. Then if we consider the developed generation of the chemistry, when we turn about the history of chemistry, we can get a general idea from the philosophers. Some philosophers like Aristotle, Plato, they have stated that everything is made up of tiny particles. Everything is made up of tiny particles. Philosophers like Plato, Aristotle, so they have stated that every matter is made up of tiny particles. Tiny means very small particles. So then a scientist stated that define what is the shape of the particle and what is the nature of the particle. That scientist is John Dalton. John Dalton stated specifically the definition of the unit or the monomer of matter. So if we consider the producing unit or the made up unit of matter, if we consider this is a matter, then the building unit of matter, John Dalton defined atoms as the building unit of matter. John Dalton defined atoms as the building units of matter. So if we consider matter, now we know the definition of the building unit of matter. John Dalton stated specifically that the building unit of matter is atoms. The building unit of matter is atoms. So he stated or he explained about atoms using some postulates. What's the meaning of postulates today? Postulates means assumptions. That means he didn't find these things experimentally. He only thought these things within his ideas, and he explained these things within his with the help of his ideas without experimentally finding these things. Those assumptions are called postulates. So John Dalton explained about atoms using his 4 postulates. So if we consider the definition of atom is a tiny, invisible and indivisible particle. Atoms are tiny, invisible and indivisible particles. Tiny, invisible and indivisible particles. So these atoms, the shape of the atoms were stated as spherical. Atoms were in spherical shapes according to Dalton's theory. He named his theory as Dalton's atomic theory. Dalton's atomic theory. The world's first theory about atoms or the building unit of matter is Dalton's atomic theory. So now we know philosophers like Plato, Aristotle, they have stated that matter is made up from tiny particles. Then John Dalton stated and defined and explained about those tiny particles, the building unit of matter as atoms. The smallest particle of matter or the smallest building unit of matter is atoms. He stated as those building units as atoms. So he explained about atoms using his atomic theory. Then he stated that atoms are tiny, invisible and indivisible particles. Today we can see an animation about atoms and Dalton atomic theory. First we will we will watch the animation and we will continue our work.
Objective: to understand the first scientific atomic theory. The first scientific theory about atom was put forward by an English chemist, John Dalton, in 1803. He described an atom as a solid hard sphere which is neutral with no charge on it. Let's understand the postulates given by him in his atomic theory. Composition of matter. Consider an element, for example gold. See what it's made of? As you can see, it is made of particles of the same type. Whereas a compound like water is made of particles of two different types. A closer look at the mixture of iron and sulfur enables us to see that it is made of very tiny particles of iron and sulfur. Dalton called these tiny particles that matter is made of as atoms. All forms of matter, whether an element, a compound or a mixture, is made up of very tiny particles called atoms. Indivisibility of atoms. Consider a piece of the metal gold. When you try breaking a piece of the metal, gold, into smaller pieces, at some point it becomes impossible to break it any further. Dalton called this smallest particle of matter an atom, and he further stated that the atom is indivisible. Atoms of similar elements. Consider a pure gold coin and silver coin. Pure gold coin is made up of gold atoms only. Similarly, in silver coin, there are no atoms other than silver atoms. If you observe the atoms of gold closely, they look identical. They seem to have the same shape, size, and mass. Therefore, it can be said that atoms of the same element are alike in shape, size, mass, etc. Now let's observe how different atoms of gold react with atoms of another element, say chlorine. The atoms of gold react with the atoms of chlorine, and they all form the same compound, auric chloride. So, Dalton, in his theory, proposed that not only are atoms of an element identical in size, shape and mass, they also possess the same chemical properties. Atoms of dissimilar elements. Let's now compare the atoms of hydrogen and oxygen. As you can see, the oxygen atom is bigger than the hydrogen atom. Also, the mass of the oxygen atom is greater than that of the hydrogen atom. If both hydrogen and oxygen are allowed to react with sulfur, you may observe that hydrogen reacts with sulfur to form hydrogen sulfide, while oxygen reacts with sulfur to form sulfur dioxide, which are two different compounds. Therefore, Dalton proposed that atoms of different elements are different in all respects. Role of atoms in a chemical reaction. When two elements such as magnesium and chlorine react, the product formed is magnesium chloride. Can you see any new atoms formed in the product other than magnesium and chlorine? No. Even though there is a change in the arrangement of the atoms in the product, magnesium chloride, it is made up of the atoms of the reactants, magnesium and chlorine, and no other. So, Dalton suggested that, in a chemical reaction, atoms of an element get rearranged but do not change into atoms of another element. The atom is also considered as the smallest particle that takes part in the chemical reaction. Indivisibility of atoms. Let's now consider a few reactions. Hydrogen reacts with oxygen to form water or steam. Let us try to find the number of atoms of reactants involved in the reaction, and also those in the product formed as a result of the reaction. On studying the chemical equation closely, we see that there are 4 atoms of hydrogen and 2 atoms of oxygen on the reactant side. And on the product side, we have the same number of atoms, that is, 4 atoms of hydrogen and 2 atoms of oxygen. Let's study another chemical reaction to understand this better. Zinc reacts with dilute hydrochloric acid to form zinc chloride and hydrogen. In this reaction too, you may observe that both the reactant side and the product side contain the same number of atoms. That is, 1 atom of zinc, 2 atoms each of chlorine and hydrogen, making it a total of 5 atoms on both sides of the equation. This endorsed Dalton's finding that atoms are neither created nor destroyed in a chemical reaction. Combination of atoms. Let's observe the formation of a compound from atoms. Here, hydrogen atoms combined with oxygen atoms to form water molecules. That each water molecule has 2 atoms of hydrogen and 1 atom of oxygen. The ratio of combination of hydrogen and oxygen to form water molecule, H2O, is 2:1. Similarly, 1 atom of carbon combines with 4 atoms of hydrogen to form 1 molecule of methane. Here, the ratio in which carbon and hydrogen atoms combine to form methane is 1:4. So, Dalton concluded that atoms of different elements combine in fixed proportions or in a whole number ratio to form compounds. Let's now summarize the points of Dalton's atomic theory. All forms of matter, whether an element, a compound or a mixture, is made up of very tiny particles called atoms. The smallest particle of matter called atom and is further indivisible. Atoms of an element are identical in size, shape and mass. They also have the same chemical properties. Atoms of different elements are different in all respects. In a chemical reaction, atoms of an element may get rearranged, but they do not change into atoms of another element. The atom is also considered the smallest particle that takes part in a chemical reaction. Atoms are neither created nor destroyed in a chemical reaction. Atoms of different elements combine in fixed proportions or in a whole number ratio to form compounds.
Okay, so now we have seen the animation about Dalton's atomic theory, and there are some postulates stated on the video also. So let's go to the postulates of Dalton's atomic theory. First of all, we should write a small note on this part. So they take paper and complete the note, carry on the note. Okay, Pute. So let's write the note on these things. Please write going to be philosophers like Plato, Aristotle, philosophers like Plato, Aristotle speculated about the building unit of matter, about the building unit of matter as small and tiny particles, which were invisible and indivisible. Do you know the meaning of indivisible, Pute? Indivisible means which cannot be divided into small parts. Indivisible means which cannot be divided into small parts. Okay, Pute? So, we have written that philosophers like Plato and Aristotle speculated about the building unit of matter as small and tiny particles which are invisible and indivisible. Indivisible means which cannot be divided into small parts. Then, right, Pute? Then, a scientist called John Dalton, had given a specific definition on those tiny particles which were named as atoms. So then now we know the smallest particle of matter is atom. So John Dalton defined the smallest particle as atom, and he had explained 4 postulates about atoms. So today we should remember those 4 postulates about the atoms, and all 4 postulates were rejected by later scientists. Since all the postulates are wrong, which were introduced by John Dalton, later scientists rejected all those postulates using experimental evidences. So now we are going to study about the 4 postulates of John Dalton. Write a topic today: postulates of John Dalton. Postulates of John Dalton. Right topic today: postulates of John Dalton. Okay, let's discuss about these postulates. So, first of all, Dalton stated that, or he postulated that, atoms are tiny, invisible, and indivisible particles. Atoms are tiny, invisible, and indivisible particles. What's the meaning of indivisible today? Indivisible means we cannot divide those particles into small parts. That's the smallest part. Indivisible means we cannot divide it or we cannot cut it into small parts. So, since this postulate was being rejected by Thomson, since atoms can be divided into furthermore small parts like electrons, protons, neutrons, since there are tiny small particles inside atoms, this postulate was being rejected by J.J. Thomson. So, this is the first postulate of John Dalton. Then, second one is atoms cannot be created. Atoms cannot be created or destroyed. Atoms cannot be created or destroyed. Atoms cannot be created or destroyed. Then today, third one is if we consider the size or the nature of atoms, atoms of a unique element, are identical in all ways. In all ways or nature. Always or nature. What's that mean today? If we consider the atoms of nitrogen, if we consider a sample of nitrogen gas, all the atoms of nitrogen are identical in size and color and mass, and every property is identical for a unique atom. This third postulate stated that atoms of a unique atoms of a unique particle are identical in all the ways. That means in size, in color, in mass, all properties are identical for a unique set of atoms, unique set of elements. Then fourth one, atoms are combined to form compounds in a simple numerical ratio. So these are the four postulates of John Dalton. All these were rejected by later scientists using experimental evidences for experiments. So first one is atoms are tiny, indivisible and invisible particles. Then second one, atoms cannot be created or destroyed. Third one is atoms of a unique element. Atoms of a unique element are identical in all ways or all nature. Atoms of a unique element are identical in all ways. That means atoms of a unique element are identical in size, mass and volume and every property. Then fourth one, atoms are combined to form compounds. Let's take an example today. Let's take sodium and chlorine atoms combine to form NaCl in 1:1 ratio. But if we consider the combination of atoms in petrol or isooctane, it is C8H18. So although the atoms in NaCl are combined in a simple numerical ratio, this is not a simple numerical ratio. 8 to 18 means it's a very large unbalanced numerical ratio. So the fourth postulate also we can reject it, since atoms, Dalton postulated that atoms are combined to form compounds in a simple numerical ratio, but they really combine in a complex ratio. They are not combined in a simple numerical ratio. So today we have to remember these four postulates from Dalton's atomic theory. So if we consider these four things, we have been given some questions for past papers between 1980 and 1990. So we can get a question for our new papers also. So you should remember these four things. And today, according to our plan, we normally discuss past papers from 1980 to 2019 using phase MCQ books. So you should keep a phase MCQ book with you. After 2 lessons, we will start our normal plan. Since we will deliver our tubes to your home, our printed colorful tubes, we have planned to deliver it to your home. So you can use that tube and you can use phase MCQ books. You should buy that from with the past paper book, and after 2 lessons, after 2 video lessons, we can discuss those past paper questions from these parts. So today you should buy those things. So can you remember these four postulates? First one, what is first one? Atoms are tiny, invisible and indivisible particles. Then atoms cannot be created or destroyed. Then to the third one, atoms of a unique element are identical in all ways or all nature. Then fourth one, atoms are combined to form a compound in a simple numerical ratio. So today these four postulates have been rejected by later scientists. Today let's write these things before going to the next part. I think we have written the topic, postulates of John Dalton. Let's write a small note. Right today, Dalton introduced his atomic theory. Dalton introduced his atomic theory. Dalton introduced his atomic theory. And explain four postulates to the easy of explanation of atomic theory. For the easy of explanation of atomic theory. For the easy of explanation of atomic theory. Okay, write the first postulate today. First postulate is atoms are tiny, invisible and indivisible particles. Atoms are tiny, invisible and indivisible particles. Put a right within the brackets. If we don't know the meaning of indivisible, indivisible means which cannot be divided into small parts. Indivisible means which cannot be divided into small parts. Write the meaning within brackets if you don't know the meaning. Indivisible means which cannot be divided into small parts. Atoms are tiny, invisible and indivisible particles. Atoms are tiny, invisible and indivisible particles. Okay with it? Then write the second one. Atoms cannot be created or destroyed. Atoms cannot be created or destroyed. Atoms cannot be created or destroyed. Third one, atoms of a unique element, atoms of a unique element, atoms of a unique element are identical in nature. Atoms of a unique element are identical in nature. Atoms of a unique element are identical in nature. Atoms of a unique element are identical in nature. Then fourth one, atoms are combined to form compounds. Atoms are combined to form compounds in a simple numerical ratio. Atoms are combined to form compounds in a simple numerical ratio. Atoms are combined to form compounds in a simple numerical ratio. Atoms are combined to form compounds in a simple numerical ratio. Simple numerical ratio. Okay, I think you have written those things. So please make a small important note using a color pen. Please put a mark like star or streak in mark and write this special note with a color pen. Please write that these four postulates had been rejected by later scientists with the help of their experimental data. So okay, you should remember all these things, and after getting our tube, all these are stated on the tube in our 4-color tube. So you will get our tube as soon as possible with the start of next month. So okay, please remember that all these postulates have been rejected by the scientists. Okay, good day. So now we have studied about what is chemistry, then what is matter, then what are the 3 states of matter and their properties. So you should remember all those things. And after that we have discussed about the elements in our periodic table and what are their states. So okay, now we have to enter our first lesson. Our first lesson is atomic theory. So today our first lesson is atomic theory or atomic structure. In your new syllabus stated as atomic structure. So now the real lesson starts. Before all these parts are some basic concepts to study the first lesson. So if we consider, now we be able to remember the development of the atomic theory. First, philosophers stated about the basic concept or basic unit. Then John Dalton stated his atomic theory. Then we are going to study about the atomic structure. What is the structure of atoms? So, first of all, the first postulate of John Dalton. Can you remember that today? The postulates of John Dalton. What's the first one? First one is atoms are tiny, invisible and indivisible particles. Atoms are tiny, invisible and indivisible particles. So, the first postulate of John Dalton was being rejected by Thomson, and before that, Michael Faraday rejected that postulate. What's the first postulate of John Dalton? Atoms are tiny, invisible and indivisible particles. So that one was rejected by Michael Faraday. So can you remember about Michael Faraday? You have studied about him in your O-levels. So if you consider Michael Faraday, he is the father of electrolysis. Can you remember the theory of electrolysis today? What is electrolysis? Electrolysis is we will enter or we will insert two electrodes, that means two metal rods into a solution. Then we will insert a battery cell, and these are electrodes. These are electrodes. Then we can see some bubbles evolving from these near the electrodes. We can see some bubbles or gases evolving by the side of these two electrodes. So this concept is called electrolysis. Electrolysis means conversion or transformation of matter using electricity. Transformation of matter using electricity. So, Michael Faraday is the father of electrolysis. Then, what's the use of Michael Faraday here for atomic structure? Today, Michael Faraday doubted that there is a particle, another small particle than atom, which can conduct electricity. Michael Faraday believed that inside the atom there is small medium or a small another particle which can conduct electricity. That's why when we supply electricity, matter can be transformed into another state. Since the matter contains a small particle which can conduct electricity, we can convert the matter into, or we can transform matter into another state using electricity. So, when Michael Faraday experimented on the electrolysis theory of electrolysis theorem, he believed that, and he doubted that there is a small particle inside an atom which can conduct electricity. So from this doubt, Dalton's first postulate is rejected, or we can reject the first postulate from this doubt. So Michael Faraday introduced three evidences for this observation. Michael Faraday introduced three evidences to prove this evidence. His first evidence is matter or charge can be, electrostatic charge can be formed by rubbing. The first evidence of Michael Faraday is, these are the evidences of Faraday. First one is electrostatic charges can be formed by rubbing. What is that today? Electrostatic charges can be formed by rubbing. What's that mean? That means if you take a small piece of paper and if you rub it in your hair, and if you toss it to another paper, that paper will be attracted to the paper. Okay, but if we rub a paper, and when we rub in the paper, there will be charges induced on the paper, and when we contact those two, these two papers will be attracted since of charges. Therefore, rather than having atoms, there should be very small charges or very small particles, charged particles inside the atoms for being attracted. So, Faraday's first evidence is electrostatic charges can be formed by rubbing. So, then how do you identify whether a piece of paper or whether any compound is charged? How can you prove that? How, if you want to prove something is charged, how can you prove that? But then there is an apparatus called gold-leaf electroscope. Gold-leaf electroscope. By using gold-leaf electroscope, we can prove that any object is charged. So here's a video. After watching this, we can talk with other two evidences. So if we consider gold-leaf electroscope, you will be taught that apparatus for physics. In the 8th or 9th lesson of physics, you will be taught that gold-leaf electroscope. For chemistry, you just remember only the name of the apparatus. Using your gold-leaf electroscope, you can prove that there is the object is charged, electrostatically charged. Okay, okay? So now you can watch the video. So now we have seen gold leaf electroscope. So the first evidence of Faraday is electricity charges can be formed by rubbing. Then second one is transformation of matter using electricity. 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 What that means, Kute? Transformation of matter using electricity. We know that if we send a current, electricity through a solution, we can transform the solution from liquid state to gaseous state. So if I send electricity through the solution, we can transform the solution from liquid state to gaseous state. So we can transform matter using electricity. So if we can transform matter using electricity, there should be a common particle inside matter and electricity. Therefore, using that relation, only matter can be transformed using electricity. So the second evidence is transformation of matter using electricity. Then third evidence of Faraday is generation of electricity. Generation of electricity by transformation of matter. By transformation of matter. Generation of electricity by transformation of matter. Generation of electricity by transformation of matter. So third one is generation of electricity by transformation of matter. So using these three evidences, Michael Faraday stated that there is a common particle or a small particle rather than atoms inside atom. So let's write these three evidences in your note. Please write that Michael Faraday the father of electrolysis, believed that there is a common small particle, inside atoms. That particle can conduct electricity. He stated three evidences. To clear his doubt about this particle. So First evidence is electrostatic charges can be formed by rubbing. 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 Write these quickly, Pute. You should increase your writing ability to answer the chemistry paper well. Second one is transformation of matter using electricity. 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 Give me an example for this concept today, for this evidence. Electrolysis is the evidence. Electrolysis is an example for this evidence. Okay, Pute? Then third one, generation of electricity by transformation of matter. Generation of electricity by transformation of matter. Generation of electricity by transformation of matter. So what that means, Pute? That means we can generate electricity by transformation of matter. What is an example? Example is dry cell, Pute. If we include a zinc electrode or a small zinc metal part and sulfuric acid, we can use that as a dry cell. By transformation of matter, we can generate electricity. So there should be a common particle inside matter to generate electricity. There should be a common particle to generate electricity inside matter. So third one is generation of electricity by transformation of matter. Okay, then the doubted particle of Faraday, the particle which can conduct electricity, which was doubted by Faraday, was named as electron. By Stoney. Stoney named that particle as electron before experimentally found it. Before experimentally found electron by J.J. Thomson, Stoney named that particle. Okay, that's the special point frequently asked for past papers. So please make a note, please put a special mark and write using color pen. Write that today. The particle which was stated by Faraday, was named as electron by Stoney. The particle which was stated by Faraday was named as electron by Stoney. So when we consider the experiment, so now we are going to a new topic, identification of electron. Don't write anything today. We will discuss this part later. So today I am going to explain the apparatus only. So identification of electron. Today there were 3 scientists involved in this experiment. This is a glass tube. We call this tube as cathode ray tube. Cathode ray tube. There are two electrodes, two metals. The positive end is anode and today negative end is cathode. Positive end is anode and negative end is cathode. Here is a large voltage supply here. Here is a large voltage supply is here and here is another apparatus, a vacuum pump. Vacuum pump. What's the meaning of vacuum pump today? Vacuum pump is a pump which can vacuum a surface, which can vacuum a tube. So today we can supply a large voltage and from anode to cathode we can send some current here. Don't think it hard. Don't take it hard. I will explain these things next week again. So today this apparatus is called cathode ray tube, or this experiment is called, the experiment used for identification of electron or the confirmation of electron. This experiment is called cathode ray experiment. So today let's watch a video about cathode ray experiment.
Cathode rays are produced in a discharge tube. A vacuum pump is used to evacuate the discharge tube. The cathode of the tube is connected to the negative terminal of the battery, and the anode of the tube is connected to the positive terminal of the battery. It was observed that, at normal pressure, the gas did not allow the current to pass through it. However, when the pressure of the tube was reduced to 0.001 mm Hg, and a high potential difference between 10 kV and 20 kV was applied, at the end of the tube, a glow was seen on the walls of glass tube. The rays emitted by the cathode travel towards anode. The attraction of rays towards anode reveals that the rays carry negative charge. Properties of cathode rays are: 1. When any object is placed in the path of the cathode rays, these rays cast shadows. This shows that cathode rays travel in straight line. 2. When a wheel was placed in the path of cathode rays, the wheel rotates. This shows that rays consist of some particle and some kinetic energy. 3. In the presence of an electric field, the rays are deflected towards the positive plate. This confirms that cathode rays consist of negatively charged particles. 4. In the presence of a magnetic field, the rays are deflected. This shows that the cathode rays are affected by the magnetic field.
Okay, Pute, you have watched the video about the cathode ray experiment or the cathode ray apparatus. Let's talk the furthermore things about the experiment and the scientists and the observations from the experiment next week. This is enough for today, Pute. So we have discussed about chemistry, matter, then the Dalton's atomic theory, Pute. Then after that, the states of matter and the properties of the states of matter. Then Michael Faraday's observations about electrolysis. Then Michael Faraday's evidences. So you should remember all these things, and you should be able to remember these things before the next class. Okay, Pute, so in next class we will discuss about the identification of electron, proton and neutron, and furthermore. So Pute, you should be able to remember these things, and please don't waste your time. Please continue work with this vacation period. We will deliver our tubes as soon as possible. After the relation of this curfew period, we will deliver our Kids to your houses today. So we will meet next Sunday also. So goodbye today. Work hard for your A-level exam. Don't waste your time, please.